Good morning, class. So, number three, real life situations are almost never flat 2D problems. Solve the following for X. So, for question 3A, what we should notice right away is what kind of triangles these are. These are right angle triangles. The reason I'm pointing this out is because that means you can use some of the pathway rules, which are right here. SOHCAHTOA and Pythagorean theorem, you can use those because that is a right angle triangle. You can also use any of these because it is a right angle triangle, so it is part of being any kind of triangle. So let's go to the first question. So start off by labeling. Okay, so this is triangle 1, this is triangle 2, let's say. These are my angles that are given. What else? Over here, I should be able to solve for these really quickly because I have 90 degrees, 35 degrees. That means I could calculate that as well as the other ones. So use your calculator and you do 180 minus 90, which is 90, 90 minus 35, and that equals 55 degrees. On the other triangle, you have a 90, 45. That means automatically that has to be at 45 degrees because you're dealing with like a special triangle. So it might be easier to work with one triangle at a time. So what triangle do you think you need to work on first? So for triangle 1 versus triangle 2, so triangle 1, I have the information that one of the side lengths is 15 centimeters. However, triangle 2, I do not have any information. So for that reason, I'm going to work on triangle 1 first. Okay, so what I mean by that is if I find, let's say, this length, which is a related length, and that is connected to this triangle, that's going to help me solve for x. And because we said this was a right angle triangle, I'm able to use SOHCAHTOA. Well, which one am I going to use? Well, this is adjacent, and for the y, that is my hypotenuse. Sorry, not the hypotenuse. That is the opposite. That is the opposite to this angle, right? I'm not going to write it down because it might. Okay, I'll write it down because only because it is opposite to both this triangle and this triangle, and so by me labeling that, it's not going to um, confuse the other parts. So for the next part, we're going to use TOA, which stands for tan theta. So we have tan theta is equal to opposite over adjacent. We have the angle tan 35 degrees is equal to y divided by adjacent, which is 15. I'm going to cross multiply, and I'm going to get y equals 15 times tan 35 degrees. And so y is equal to approximately 10.5 centimeters. And so this is the length I will work with. And keep in mind that in my calculator, I try to keep the exact version when I'm looking and working on the future calculations. So it's another right angle triangle, so I'm going to use SOHCAHTOA again. Reason why I don't use Pythagorean theorem is because I don't have the other length, so it's not going to be helpful for me. All right, so I have the sine theta, which is equal to opposite over hypotenuse. And why did I use that? Well, that's because I have sine 45. I have my opposite. I need to solve for my hypotenuse. And based on that, that is why I circled so. Oops. All right, going from there, I have sine 45 degrees is equal to opposite, which is y, and hypotenuse, which is x. Now I'm going to sub in what I know, and I know my y value, which is 10.5. Notice it's important to like label everything out, because if you don't label and you just kind of plug in, it's going to be hard to follow. So I had to introduce a variable as I went along. And so I need to solve for x. And this is kind of like a half cross multiplication. Basically you multiply and I will get, well, 10.5 on one side, and I will get x times sine 45, but I'm going to divide that anyways. So see how I divide that part anyways? I'll just keep it for now. But sometimes you'll see me doing a half cross multiplication. But this time I'll just do the full cross multiplication so I don't lose any of you. So I have the following. So I have x equals 10.5 divided by sine 45. Recall that I'm using the actual exact version in my calculator, and x is equal to 14.9 centimeters. So therefore, x is equal to 14.9 centimeters. And just so that I don't confuse the reader, I'll just unhighlight this part because that wasn't my main answer, but this was my main answer.
Okay, let's take a look at question B. I'm going to first start off by again labeling the triangle as triangle 1 and triangle 2. Let's see, we have a right angle triangle for triangle 2, and triangle 1 is an isosceles triangle because of those lines that indicate that these two sides are the same. So that means that this part is also 34 centimeters as an FYI. Okay, so if I need to solve for x, and it's kind of similar to the previous case, like I do not have any length information from triangle 2, that means I need to grab some information from triangle 1. And so from triangle 1, the related kind of length is this one again. And so I'll label this as y, let's say again, and I'm going to solve for y first. So for my triangle 1, I'm going to solve for y. And remember, because this is not a right angle triangle, there's no 90 degrees. Does that mean you can use SOHCAHTOA or Pythagorean theorem? You cannot use either one because it's not a right angle triangle. So what that basically means is following that pathway, I can only use the cosine law or the sine law, any of these three. So going back, basically, I have a side, an angle, and a side, and the way I said it, it was a side, angle, side. So it's not side, 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 so I don't use that one. And I don't, I'm not going to use the ones where I have to have the corresponding ones, because although this angle corresponds to my length y, I, for example, don't know the corresponding angle, the b, that corresponds with this length 34. So that means I can't use sine law, but I can use the cosine law that says side, angle, side. So that's how you kind of break down what you can use. And sometimes you're able to use more than one law if you have more information. But based on this information, I can only use side, angle, side, cosine law. So the equation for cosine law is y squared equals, it's basically like the other side. So I'll just say, wait a minute, I'm just going to change this around to meet everything. So let's say if I label this C, that means that this length is C, and this is length B, and this is label D. So I actually have to find D. I mean, they're just letters, but just so that I can keep it really concise, for the cosine law that I'm going to use is D squared, because that's what I'm solving for, the D. I add up the other ones, which is B squared plus C squared minus 2BC cos angle D. All right, notice how it's sensitive to whether it's a capital or a lowercase. So let's go from there. I'm going to sub in. So D squared is equal to, B is equal to 34. So 34 squared plus C is also 34 squared because it's an isosceles triangle, minus 2 bracket 34, 34. Cos angle is 70 degrees. So let's keep going. If I put all of that in the calculator, I ended up getting a value that was like 1521.24 dot dot dot. Okay, and as a next step, I want to get d by itself, so I need to square root both sides. I made sure I didn't lose this on the left, because sometimes some people might just like assume and not write anything, and then they suddenly have their variable. But we have to remember that we have to like square root the both sides, because it started off with d squared. So when you do that, we're getting d is equal to approximately 39.0032 dot dot dot, keeping everything. But that is approximately 39.0 centimeters. Again, this isn't the final answer, but this will help me go to my second triangle, right? So my second triangle, I need to solve for x. So let's interpret this triangle. So it's a right angle triangle, which means that I can use Pythagorean theorem or SOHCAHTOA. I have this available, and I have an angle. So a couple things you can do. One thing you can do is you can use SOHCAHTOA. And I find that easier when I'm dealing with the right angle triangle. Or you could have maybe used the sine law, because these are corresponding and these are corresponding. But I'm going to try to use the easier option, which is using SOHCAHTOA. And which one am I going to use? Well, I have an angle, I want to solve for hypotenuse, and I have the opposite. The letters I have used are so. So I'm going to use so, meaning sine theta equals opposite divided by hypotenuse. Plugging in, I get sine 27 degrees is equal to d divided by x, and d is equal to approximately 39.0, and then divided by x. So let's do cross multiplication. I get x times sine 27 degrees equals 39.0, and you divide it by sine 27 degrees, divided by sine 27 degrees. You can go straight to x equals 39.0 divided by sine 27. You just want to make sure that you're getting that correctly and not have it like the other way, so x is equal to 85.97 centimeters approximately. Okay, let's take a look at question C. Again, with these triangles, you want to interpret and see if you're dealing with a right angle triangle or not. So I am dealing with a right angle triangle. And going from there, so this time I labeled it triangle 2, triangle 1, mainly because it doesn't really matter if you labeled it the other way as long as you're getting the same answers as me at the end. So for triangle 2, I'm solving for x. For triangle 1, I have the length. So you can guess that I'm going to work from my triangle 1 to my triangle 2, consistent with my previous questions. So for triangle 1, I am going to solve for what? Well, I need to solve for my length that is related to it. So this I'm going to label as G, and this is length D, because the angle D corresponds to this length D, this length G corresponds to this angle G. So because it's a right angle triangle, I'm going to use the easiest option, which is do SOHCAHTOA. Between the SOHCAHTOA, I right now have the adjacent to my 41 degrees, my reference angle, my G is my opposite. And so if I am using opposite and adjacent, that means I need to find and use TOA. So tan theta is equal to opposite over adjacent, right? And I have tan 41 degrees, where opposite is the one that I don't know, and I'll label it as G for now. And adjacent is 11. I'm going to do cross multiplication, and so G is equal to 11 times tan 41 degrees. G is approximately equal to 9.56 centimeters. So after that, let's go to step 2. So now that I have the information from triangle 1, I can move on to my triangle 2, and I can solve for what? I can find x. Okay, when I go and find x, I need to evaluate what I need in terms of SOHCAHTOA. So take a look. I have my G, and to my reference angle 32, my G is the opposite again, so I can keep that as is. I have my hypotenuse, or I need to solve for my hypotenuse. So when I'm dealing with opposite hypotenuse, I see O and H within SO. So I'm going to go from there. I'm going to use so it's sine theta is equal to opposite over hypotenuse. And so sine 32 degrees is equal to opposite, which is G, hypotenuse, which is x. So sine 32 degrees, well, G is 9.56 centimeters divided by x. Let's see cross multiplication to get x by itself. So x sine 32 degrees. By the way, it's a very bad form if you put, let's say, this x after sine 32, unless x is like part of the sine input. The coefficient has to be in front of the function, okay? So always put that x as or any number in front of sine, whatever that input is. And so I'm going to divide it by sine 32 degrees. And x is equal to approximately 18.0 centimeters. So question D, so this is a triangle that has like 4 possible triangles. There's one there, 1, 2, 3, and then there's one overall. Interpreting it, this triangle seems to start off with more information. I'll label it as 1, 2, 3 for now. Okay, and just because I have the most information from triangle 1, I'm going to try to solve for x. Notice it's not a right angled triangle for my triangle 1, but then the triangle 2 and triangle 3 is. Okay, so that's just my side note. Let's go from there. So according to my triangle 1, I have an angle. I have 2 sides, and I need to find this side. So I find that it's a side angle side example again, based on what I'm given. And again, I'm going to modify my choice of variable based on my coordinates, and I'm going to relabel this as side D, and this as side B, and this as side C. Okay, let's go from there. So I usually like to start off by writing down the equation once. So my equation is, well, I want to solve for D. And so I have D squared is equal to, the other parts are squared and they're added. I'm going to subtract it by 2BC cos D, angle D. Let's plug in what we have. So B is equal to 13, so 13 bracket squared. C is 15 bracket squared minus 2. I have my B as 13 and my C as 15, and cos 88 degrees. So based on that, you plug it in, and sometimes I provide more work, but for now, I'm just going to write down my answer that I get once I put all of this in the calculator. Sometimes I like to put it in steps, like this part, and then this part. For this version, I have 380.38 dot dot dot. At that point, I need to square root both sides. Because I'm dealing with side lengths, I only have the positive 1 to grab. And I have D is equal to approximately 19.5036 dot dot dot. So remember, my side length D, that is not what I want as my final answer, and that's why I do try to keep the exact version kept in my calculator. So that is my first step, finding my D. Okay, so let's walk it through. I found my D. And for a second, let's look at the whole big picture. Although there are 1, 2, 3 tiny triangles that make up this big triangle, I need to actually find the theta of this big triangle, right? So that means I might not want to focus too much on the little triangles right now. Now that I have this length of this bigger triangle, I want to label these two out. So for now, I'm just going to give it the letter Z and Y, something that's not going to conflict with the smaller triangles. And so what can I do as my next step? Okay, so basically what I'm finding is, okay, although I want to get to my angle A, this seems like I need more than one step here. I, for now, worked with my triangle 1. If for me to look at and find Z or Y, it seems like I could use either of Z or Y, keeping in mind that I have a right angle triangle involved. So, for example, I noticed there's an 11 there and a 15 there. There's an 11 there and a 13 there. So technically, as my next step, I could use either or and find my Y and Z respectively. So as my step 2, for now, let's say I'm going to find Y. And it won't really matter whether I find Y or Z first because I have the exact same information from there. So I'm going to do what to find that. So because I have a right angle triangle, although it might not look like in the picture, the little square part confirms that this is a right angle triangle. So with a right angle triangle, I can use SOHCAHTOA or Pythagorean theorem. Because I have an 11 and I have a 13, and right now I'm not dealing with any of the angles involved, that means I can use Pythagorean theorem. General formula for Pythagorean theorem being a squared plus b squared equals c squared. For this part, that just means that, well, I'm really solving for the hypotenuse, and then I need to square these ones and add it up. So I am going to get 11 squared plus, the other number was 13, so 13 squared equals c squared. So that's going to equal to c squared equals 121 plus 169. So c squared is equal to 290. I'm going to square root both sides, and I have a positive negative. Because we're dealing with lengths, I'm going to grab the positive one only, right? And so c is equal to approximately 17.0 meters. And I'm just going to quickly label, erase, and write this as y. Y, 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 because I was finding y. Okay, and I said I could also find the other side length. Why do you think I'm going to find find z, the other side length? Can you see why I'm planning this out this way? Well, it's because if I'm able to find Z, what law am I working with? Because overall, this triangle is not a right angle triangle, right? This big triangle 4. So the reason is because if I have these 3 sides, that means I could eventually find an angle from this triangle. And remember, I didn't have any really angles from this big triangle. So I could use side, the cosine law to eventually find my angle. So that is kind of my thinking process of how to kind of break this down. And this plan became more concise and clear as I had more information and I can plan out my next steps to get to my final answer. So for finding Z, I have a squared plus b squared is equal to c squared. When I plug it in, I'm going to have 15 and 11. So 15 squared plus 11 squared equals z squared. So z squared is equal to 225 plus 121. And z squared is equal to, what do I have? 346. I'm going to square root both sides. When I do that, I'm going to grab the positive one only because we're dealing with length. So z is equal to approximately 18.6 meters. So at this point, what is going to be my step 4? Well, my step 4, like I said, is we're going to use, we're going to find theta using cosine law. And which part of the cosine law? Well, I have my side. Well, my equation is cos theta is equal to, so I really have cos theta is equal to, basically, I'm going to add up the other sides, y squared plus z squared. That's kind of how I remember it. I've subtracted by the side that's across from it, divided by 2 times the other side lengths are going to be multiplied, and let's plug in. So cos theta, I don't know my theta. My y is equal to 17.0, that's the green, and my z is equal to 18.6 squared. And I don't have the brackets in because I know I'm dealing with positive for side length. That's the only reason I don't have the brackets. So I have minus 19.5 squared divided by 2 times 17.0 times 18.6. And I'm just going to make this more obviously as 6. Okay, going from there, if you work this out, you get a number like 0.40228, and I hope you don't stop there because it doesn't make much sense. You do have to cos inverse both sides to get the theta by itself, and so theta is equal to, if you cos inverse that, I'm getting 66 degrees, not exactly, but 66.2487, which I'm going to approximately state as 66 degrees. Okay, so I get this as the final answer. Hope it made sense. The breakdown was, I realized that there were some right angle triangles and non-right angles involved. I wanted to work with the triangle with the most information, which was this one, found the side length, and then went ahead and found the respective side lengths of this overall triangle. And then I tried to find the angle, one of the angles based on side, and then I got the angle.